and also you get no INST. Now here if you see, because you have DB tag also, so this is what exactly DB tag. Machine, physical machine is one, but how many tags are there? 2 tags. This is what? Apps tag. And this is only what? Apps tag. Now tell me how many apps tags are there? Total how many apps tags? Total apps tags are 2. This is apps tag and this is also. So we have 2 apps tags. Okay, so complete after doc, comma doc. Now in terms of service, you can configure any service like doing installation time later. What do you want to run here? You know, let's look at the best practice. What you should run here with service, or you better run CMS. Why? The CMS has dependency. And there is another service depends on CMS. What is that? Application listener. Right? So here which service will be there? So first, let us start. Under RDBMS home, under this DB tag, what are the services are there? You know very well. 2 services are there. Instance. Let's say the name of the database is prod, so instance name is prod. This is service. Instance is a service. And then next is database listener. Database listener is also prod. So similarly, these are the services, right? So you have application services. So application services. So what are the application services are there? Like CMS, Apache, Forms. So these services you have to start. As you start instance, as you start listener, so you have to also take care of these services, application services. So here, what service? CMS, concurrent manager server, and then what? Application listener. We already discussed what is that. And then here what? Here you have HTTP, that is what? Apache service. Apache, what is exactly Apache? Listener. And the next is what? Then OC4J. OC4J instances. OC4J instances will be there. So for example, OC4J which instance? OA4. And then again which service here? Form service. So this CMS and application running under this application tech stack, and these all services running under this tech stack. And within tech stack, you have 2 homes are there. So later, if you just you don't want to run CMS there, it's very simple. Now you can run CMS here also. But because we have complete application files. Or if you want to run forms there, you can run it. Because all the files are there. Easy. That we are going to see practically later how to change the services. So it doesn't mean that forms is running here, means it should be always here. So forms can run there also, or CMS can run here also. So that means if you are even talking about 3 node, third node also, then in this third node also you will be having what? Again same, isn't it? What is that? Tech stack, app stack, and INST, complete. Right? And in the last session we discussed that if you have 3 nodes, better you keep forms here. Forms here. So where is the forms? Form service. So look at here. Here you have Apache and OC4J OA4. Forms, CMS, and ready. Now total how many applications are you have? 3. Okay, 3. Okay. You can give the name, say for example, Apps3 node. Apps1, Apps2, Apps3. Okay. Well, actually, we we just have to make some configuration changes. That's it. You have to make configuration change. For example, it is like this. You don't want to run form services, so you disable here, you enable here. So that is the change. Enable, disable, enable. First you disable from one node, enable in another. Disable or enable. That's it. So you can run, you can configure this service anywhere. So we are going to discuss, of course, about this, application file system, upper top, common top, tech stack more in detail. So this is in terms of, this is e-business suite in multi-node environment. E-business suite in multi-node. So how we can manage a single e-business suite instance in multi-node. And I'll just give you an idea. We'll be discussing later about this. Load balancing. When we say load balancing, so load balancing means, you see the same form service is running in more than one node. So that means you have more than one form service. Apache, more than one Apache. This is what? Load balancing. Like for example, you do database load balancing. Database load balancing means we are talking about what? RAC, real application cluster. So you will be having one database but multiple instances. So one database, multiple instances, that database load balancing. Here you will be having multiple application services, multiple database services. Multiple database services, instances will be multiple, listener will be multiple, database will be one. Here you have same application files, but services are multiple. Application file will be the same, but you will have 2 Apache, 3 Apache. You can have 2 form service. This is what? Load balancing. So for load balancing, of course, there are some additional services required to be configured. Additional services are required to be configured. Oracle e-business would support load balancing of form service, load balancing of CMS, and load balancing of Apache. But Apache load balancing requires hardware load balancer. Form server load balancing can be done with software load balancing. So this idea is like this. How we can have the load balancing here now? So here if you see, now if you can look at how many form services here we have. Now here you have the DB tab and the CMS concurrent manager service, and here you have Apache and OC4J for the HTML based application, and then here you have form service, only one form service, right? So Apache will pass, Apache is going to route the request to only one form service. Only one, right? Because there is only one. So whenever user wants to access any form based application, GL, AP, AR, so who is going to route the request to form service? Apache. You recall, you recall, right? We discussed, right? First authentication is done, and then user connected to PHP. When the user select the responsibility, what happens? The moment user select the responsibility, then the Apache will hand over the connection to either OC4J, OA core, or form service. So from Apache, it is coming to forms, isn't it? But there is only one forms. If that form service is gone, so user cannot access. First. Second, all the load is coming to one form service. So I can say that up to now the performance can be good, scalability. That means scalability, like we have separated the services. We have separated the Apache, OC4J, the CMS, the forms, we have separated. So for now, what is the next step? What is the next step now? To have more better improvement performance, what is the next step now? So the next step is don't try to take out CMS. The next step, don't take out CMS. Keep the CMS along with the database. Okay. So you got 3 nodes, you did. When you have a 4th node, what do you do? Take out CMS. No, don't do that. Instead of that, better go for load balancing. Load balancing of what? Form service. Load balancing of Apache. So when you want to go for load balancing of form service, now again you will have what? Another node on that machine. The basic idea. But again the thing is that, the process is, you know what, if you think that in an existing environment, how I'm going to do this? So first of all, you need to again have all application files, 100%, complete files, meaning what? Upper top, complete tech stack, app stack, and complete file system you need to have. And you know what? How we're going to do this? Through cloning. And that you are going to see in cloning. So now either you copy from here, you copy from here, or you copy from there, isn't it? So from anywhere you copy. So now you'll be having what here? Again what? Tech stack. Again what? App stack. And then inst, complete files. And what service you would like to configure? You can configure which service? Form service. That's it. And now how many? 2 form service. 2 form service. Just give it. Now look at here. But let's see the more. I'll just explain a little more on this. Now, when Apache is going to hand over the connection to form service, now there are 2 others. Now the question is, Apache is going to hand over to which form service? Okay, to which form service? So here, look at here. So we have some additional services here. We have, this is very brief, additional services we have here. So here in this machine, we have one additional service called metric server. Metric server. Here we have metric client. Say for example, metric client 1, metric client 2. Okay. So we have here some additional services. So what are the services? Metric server and metric client. So this is load balancing. Metric server is called load balancer. This is load balancer, and this is what you know. This is agent. Load balancer agent. The metric client will be always updating metric server about the load of the form service. So who knows how much load is there on the form service, on this form service, on this form service? Who knows? Metric server. So very simple. Now Apache, before handing over the connection, Apache is going to ask metric server. Very simple. Metric server will provide the address of the least loaded form service. So metric server says that there is a less load on the form service which is running on Apps3. This is Apps4. So now, who is going to hand over connection to form service? Apache only. But by asking what? Metric server, the load balancer. And then metric server says pass it there, it will go there. Metric server pass it there, Apache will hand over to this form service. So the session will be divided, the load will be divided between this and this. And if this form service is done, then we can configure in such a way that, you know what, if this form service is done, then it should go there. If both form services is done, we can configure in such a way that it should display a common page that form service is disabled something or some issue. So this can be done. So this is example of software load balancing. This is example of software load balancing. And how we are doing this software load balancing? Through metric server and metric client. Metric server is a load balancer. Metric client is the agent. So who knows about the load? Metric server knows. Who is telling metric server? Who is updating metric agents? The metric client. This is just a very brief idea about it. So the reason why I am saying, because later whenever you come across these services called metric server, metric client, then you must understand that okay, metric server, metric clients are used only for load balancing. If no load balancing, then there is no role of metric server, metric client. No load balancing, no metric server, metric client. For form server load balancing, there must be metric server and metric clients. And how many metric server, metric client? I don't know. You can look at the picture. You can say, right? There is one Apache, one metric server. There are 2 form server, 2 clients. 3 form server, 3 clients. Isn't it? So well, here, let me tell you one more time, the only problem is, it's not a problem, but you see the way you look at it depends on that. Complete file, So redundancy, okay. All files are here. Redundancy. The space will be little more occupied. Okay. Even there is only one service is there, forms, but all files are there. You don't need so many files here. Java files are here. HTML files are here. So many are, which is not written. But Oracle say no. Complete files will be there. So many files are not written. Even reports are there. Do we need reports here in this machine? We don't need reports. Form service now. Only we need forms. Here you have reports, everything. This is main fix in your mind. That every application download comes with complete files, irrespective of service. And then there are advantages are there. You can configure it. Nowadays, are you concerned with 10 GB, 20 GB? 10 GB, 20 GB is free available in the internet. So they say don't worry about that. Okay. 10 GB is wastage means what? Waste. Somebody asked me something. Repetition. Same files are repeated. I'm just using the word. Because forms are here, forms are here, forms are here, forms are here. But where you need forms? You need forms here only. See, reports, where you need reports? Tell me. Reports where you need? Apps note 1, 2, 3, tell me in terms of that. Where you need reports? 1. Why? Because CMS is here. But reports are here. Reports are here. Reports are here. But they are, okay, you should leave it. You ignore it. Okay? The reports are here, here, here. Files are there. But service is where? So this was just an idea about multi-node with load balancing. Okay. And then Apache load balancing anyway, just we'll be discussing later. That's a hardware load balancing. This is software load balancing. So one more time. This metric server, this metric client, these are software services. Software services. Metric client is a service. Metric server is a service. Metric server, metric client. Load balancer and API. Okay, so let's continue today's session. Well, actually today we are going to talk about, we are starting with the multi-nodes first. In business you saw multi-nodes are there, multi-homes, right? Multi-node, multi-homes. In single node, how many homes? 10.1.2, 10.1.3 are divided. So let's start with this. EBS multi-home, e-business suite multi-Oracle homes, which is called partition mode. Then next we look at e-business suite data model. And then next we are going to talk about application file system. But first let us see this. So how many homes are there? 3 homes are there, and this is exactly called e-business suite partition mode. Your Apache service, your OC code is running in separate home binary, your form service is running in a separate binary, isn't it? And your CMS is running in a separate binary, and your database service is again running in a separate binary. RDBs. Okay, why? So first this, okay, partition mode, EBS partition mode or e-business suite multi-Ora homes, which is called partition mode. So if you look at here, we have 3 Oracle homes are there, right? We have Oracle home, Oracle binaries. We have an Oracle home for serving database. We have a separate Oracle home for application. For form-based application, we have a separate Oracle home, 10.1. And then this is another separate Oracle home for form-based application, for history-based application. This particular Oracle home for database, this is which home? It is called RDBMS home. So what are the advantages of these three home? Why we'll see that. Okay. So here you have a database. Fine. Now this particular home is, let's say, for form-based application, for this is tools home. So this is which home exactly? It is exactly 10.1.2 home, which is called what exactly? Tools home or C home. Tools or C home. So basically the C program is going to run. Okay. So you can call C or tools home. This is what? Java or web home. So your form-based application mostly here, your HTML-based application is here. Now let us look at in terms of services. Which service is going to run under which home? And the version also we'll see. So actually this is what? 10.1.3. This is application server version, application server 10.1. Actually the Oracle binaries is 10.1.2, 10.1. Actually Oracle home is 10.1.2, 10.1. 10.1, sorry, 10.1, 10.1, 10.1, 10.1. Actually what exactly? 10.1, 10.1. So your Oracle binaries are what? 10.1, 10.1. This is application releases. Application releases. But Oracle home release is what? 10.1, 10.1. What is the Oracle home version here? 11.1. We are talking about what? Release 12. Which release? 12.1x. In 12.1x, latest 12.1.1, 12.1.2, 12.1.3. In the latest release, what is the RDBMS home? RDBMS home version 11.5.1. Of course, it can be released to also, but what comes with the software here? So when you are installing e-business suite software, so it is coming with three Oracle homes. RDBMS home 11.1 for database services. 10.1.2 home. See, that is called tools home. 10.1.2. Application server 10.1.3 using 10.1 home. So both application 10.1.3 and 10.1.2 both are using 10.1 home, but separate home, separate home, separate home. This is exactly called partition mode, e-business suite. Okay. Now look at here. Services. What service is running under here? Instance. Correct? Instance. And then listener service. Which is the service? Database, listener, database, instance. Two services. Whatever the name. Two services will be running under RDBMS. Now you know very well what are the services running under, you know what, under 10.1.3. It is mainly, first let's start with what? Apache. Apache service or Apache, you can say listener. Apache service or Apache listener is running under 10.1.2 home, the web home. And then what next is running here under OC4J, which instance? OC4J OA code. Let me tell you one thing, if forms is running, forms is also running here only. Even what is running here? OC4J forms also. And even OC4J OA FM1. Now look at here, your forms service executable file. Your form service executable file, there is something called FRM variable. This is your form server executable file. Your form server executable file is under 10.1.2 home. Your form service is under 10.1.2, but the instance running under 10.1.3 because it is default is what? Servlet, right? Default. At the moment, see, OC4J forms means you must understand. OC4J forms means servlet, and only form service means when we say form service means socket. OC4J forms means servlet, and by default it is servlet. By default it is servlet, and once you change from servlet to socket, it is there. It will be started here. But yeah, the OC4J servlet engine it is starting, but it is using which executable to start form service? FRM web. Where is FRM web executable file? Under 10.1. the form service executable file is there, but form service is here. Instance, form service, it is called instance. It is called instance. OA core instance, form instance. This instance is nothing but what? JVM processes. JVM, right? We discussed the JVM processes. Now, if you look at first, why there are 3 homes are there? So it's here. And what services running here then? CMS. Service as well as application listener service. So application listener and CMS. This is actually database. That's it. So CMS application listener. And those instances there. Okay. Now, why there are 3 homes are there? So the answer is, so basically, you know what? For backward compatibility. And second is to make database independent of application. I'll tell you what is backward. So you see, and the stability also. Your 10.1 binaries are more stable than 11.1. So application requires a binary which is more stable, isn't it? So for example, like say 10G, 11G binaries, which is more stable? 9.9 or 10G, which one is more stable? 9.9. In terms of features, of course it is 10G. In terms of feature, of course it is 11G. But in terms of stability, it is more about what? 10G. So Oracle is looking for what? Stability. The code stability. If application is using a particular binaries, that binary must be very stable. So look at that. 11, 10, which is better. 10.1 is better than 10.2. And after it is better than 11G. Isn't it? Because so many bugs have already been fixed. Today, if you look at 11G release 2 is more worse in terms of bugs, right? 11G release 2 is more risky compared to 10G, isn't it? In terms of what? Issues, problems, isn't it? So Oracle said that Oracle need more features for database, not for application. Listen, what is the idea behind these binaries? These binaries are only going to support services. So you don't need latest features. You need latest features for database. So that's why your database is running under latest binaries. Your database needs latest feature, ASM, data, ASM, or you talk about latest features, whatever, ASM, in terms of performance, in terms of scalability, in terms of high availability, latest features, your database. So database running under 11G. Your application only need the binaries for just running the software code. Fine, stable. They are stable and compatible. Good. Second, if you look at why, okay, let it be, like say, even if it is say, why not say one common home? And what is the advantage of these 3 homes? See, the advantage is not this. If later, if we are going to upgrade this database from 11G release 1 to 11G release 2, now we are going to upgrade. So when you upgrade this, only which binaries will be affected here? Only these binaries, right? Isn't it? Only these binaries will be affected, right? Now look at here. So we'll be having new Oracle binaries. What is this new binaries? 11.2. This is new binaries, new Oracle home, new article 11.2. And then we will do what? We will upgrade this. Upgrade the database. After that, which binary you are going to remove? Okay. Now tell me how many homes are there now? 3 homes. Before 3, now 3. Now tell me, is there any change on application side? No. Is there any impact on application side? No. No impact. Now your database is upgraded to what? 11.2. So which binary, which RDBMS home we have removed? Old RDBMS home. Now your RDBMS home is 11.2. And perfectly okay. Now your same 10.1, that 10.1 and this, that what you call that, the C tools home and this web home is still the application supporting, and then you find it so. Right. So you know what? Under this Apache, all the services These all the executable will be linking to this 10.1.3 home. And how Apache is going to connect to the database instance? Through which home? 10.1.3. Directly 10.1.3 to database listener to instance. So it is not, these services will not be using this RDBMS home. Who will be using your RDBMS home? Your database services, instance and listener. And now you got it. So when you upgrade, fine, you don't need to do this. Okay. And in 11i, this was 8, it was 8i, and that was 9i. 11i, what were the tools home? 8, and what was the web home? 8i, and the RDBMS home was 9. 8i, 9. In R12 it is 10.1, and that is 11. In 11i, 11i. 8i, 9i. Okay. So you have any question? So what we are discussing? 3 homes of e-business. Why there are 3 homes? What is the advantage of 3 homes? What is exactly the known as? Which service running under which home? If you have any question, you can ask me. And you got it this in multi nodes, in multi application plan nodes. How many 10.1.2, 10.1.3 home will be there? In multiple application plan nodes, how many this tools home and web home will be there? Multiple. Per application tag, there will be 1 tools home and 1 web home. In each application tag, there will be 1 web home and this. And because your database is always going to be one database, so RDBMS home is going to be 1. And you see, the backward compatibility is always there. You can connect from 10G to 11G, you can connect from 9i, 8i to 10G or 11G, but not vice versa. So the forms, the CMS, the Apache, which is running under 10.1.3, can connect to instance which is running under 11.1 or 11.2. So that means the client must be equal or less. The client binaries must be equal or less than the database. Here it is less, right? So fine, backward compatibility. So you can connect from 10G or 9i home to 11G, but not vice versa. You cannot connect from 11 home to 10G home. You cannot connect. So I don't think and I don't see there is any greatness here. Only very simple, we have to remember, okay? And don't think too much also. Some places you don't have to think too much. Somewhere you have to think too much. Very good. Here no need, take it easy. That's an idea. There are 3 homes are there. Don't start thinking, simple. 3 homes are there. Which service running on, that's it, finished, over. Came out? Still in 3 home? No. Simple idea, not tough, very high complicated idea, nothing. So 3 homes. Remember which service running on which. Now, you see, we are going one by one. Now we discuss e-business suite database. When we install this e-business suite software, a database is created with complete data model. So in this data model, you will be having all the, schemas. All the schemas will be created. Schemas with all the, the schemas, all the objects, and then with all the table spaces. Okay, schemas, object, user IDs, users, table spaces. So of course we must understand that. I repeat again. When we install e-business suite software, a database will be created. At the time of installation, one e-business suite database is created, and this database is created with all these schema, user, and table spaces. Now we must understand then how this database is created, and how many schemas are there, users are there, and table spaces are there. Okay. So look at it. It is just an idea. So when you install e-business suite, a database is created. The normal database is created. So we are never going to create database. Always a database is created. I think here we have a problem. This AC is a problem. I think that's why. Now you can understand better, right? Subject is hot. And this temperature is hot. So this database is created the normal with all the required tables, systems resolved. And then in these table spaces, in this database, all additional table spaces will be created at the time of installation. So we have to see what are the table spaces are created. And then all the users accounts will be created. Users. For every module, for every e-business suite module, one user will be created. For every module, one user will be created. And then in that user, schema is going to build. Schema will be built. Schema is created. Schema is nothing but what? All the objects. So we must understand about this object schema, this user, this table spaces. Okay. So once we have installed the software, this database will be there with all the table spaces, users, and schema. And the objects. For example, for Oracle General Ledger module, there is one user called GL, and based on the module, the user short name. For Oracle Payables, AP. For General Ledger, for HR, there is a short name is actually per. And for inventory, INV. For every module, one user. So we will see this part. So for every module, one user, that means one user means one schema, and how these modules have been integrated, how all these e-business suite modules are integrated. So that also we have to understand, okay? So first we will start with these users. Now see here, when we install e-business suite, all these users are created, and these users are created for what? For module, for every module, isn't it? So before that you have to understand, in e-business suite, the e-business suite we have various modules, right? Every application is basically maintained as a module, products. You can say e-business suite modules, or you can call what? Products, isn't it? So there are two types of products out there: technology specific and business specific. Technology modules and business specific business modules. So how many types of modules we have? Technology modules and business, in short, business specific module. Okay, business module, business specific module. So this business specific module you people already know, like this Oracle General Ledger, Oracle Payables, Receivables, okay, fixed asset, inventory, purchasing, these all are business module. And how about this technology module? See, to manage, to maintain all these business module, Oracle people have developed and provided some technology module in e-business suite. And those technology modules, most of those modules we have to work on. So we are going to use those technology modules. So to manage, there are so many business modules, there are some technology modules. Okay? I'll give you first the two important technology modules of e-business suite. The first module name is actually application object library. What is that? Application object library. Application object library. You say application object library, or you say AOL. Actual short name is FND. So what is the short name? FND. So what is the name of the module? Application object library or AOL, whatever. But what is the short name? FND. FND stands for foundation. Okay. So there is a module called application object library. So this application object library is one of the module of e-business suite, is one of the product of e-business suite. Okay. And then we have another module called application DB. Application DB. And this short name is AD. AOL, that is a FLD and AD. Like GL, APAR, these two. So first, there are two main technology modules you have to understand. AOL and AD. Okay. So I will brief you on this AOL and AD, and we are going to discuss more in detail later. So you have various modules, more than 200 modules are there. Here there are only few technology modules are there, and among all technology modules, two modules are very important for you. One is AOL, the other is AD, application DBA. Application DBA means what? It is the name of the module. Application DBA, short name is AD. It's the name of the module. And there is another module called AOL, application object library. And then remaining all are business module. HR, manufacturing, CRM, customer relationship management, all. So this is just brief about types of modules. So two modules. So first we will look at briefly about these two modules. Application object library, AOL, which is the FLD. FLD stands for foundation. And second is application DBA or AD. What is exactly this module called AOL? And actually short name is what? FLD. Which is what? Foundation. This is one of the most important product module of e-business suite. This is the central repository of e-business suite. Central repository. It is a e-business suite central repository. E-business suite central repository. You can even compare this with data dictionary. In Oracle database we have data dictionary, right? All the metadata is going to be stored in data dictionary, right? So database metadata is where? In data dictionary. Where e-business suite metadata is going to be stored? AOL. So you can compare, this is like a data dictionary, e-business suite data dictionary. It contains e-business suite metadata. Okay, e-business suite metadata. So AOL is a central, a central e-business suite repository, a central e-business suite repository. Now repository is a centralized information. Again, e-business suite repository means it's an e-business suite repository. So this repository contains what? All EBS metadata. What does it contain? E-business suite metadata. You can compare with database. You can compare with database data dictionary. Okay. So initially, yes, you can compare them. Okay. So what is data dictionary to database is AOL to e-business suite. Okay. So all the e-business suite metadata. In e-business suite, how many modules have been installed? How many modules have been licensed? In each module, how many forms are there, reports are there, how many users are there? All this information is in AOL. That's why we are saying it's a central repository. All that. This is brief one. Later we will discuss in more in detail. So this is AOL. Apart from that, this AOL provides common features to all the modules. Provide common features. It provides common features to all modules, to all business modules, to all the business modules. Now look at that example of these common features. You know very well. One example at least you can understand that SRS. We already discussed. What is SRS? Standard request submission. How does the user submit a request in GL module? SRS. In AR module, SRS. In HR module, SRS. Meaning what? Common, standard. Common, standard. In any module, the same SRS. That means common standard interface. So common standard interface. So you can say common features, common standard interface. So what is the screen where users are inserting this submitting requests? SRS. But that SRS belongs to whom? AOL. And see, we already discussed that. Look at that. Just an idea. So there is a user, he is entering these requests, there is a form, he is entering a request in this form, and the request is going to what? Database. Which part of database? AOL only. What is the table name I told you? FND concurrent request. See, FND is what? It's an AOL table. So just you have to understand one thing, that this SRS is a feature of AOL. SRS is a part of what? AOL. It is providing a common features to all the users. So user can submit requests by using one standard screen. So whether users are entering requests in GL or AP or AR, they don't feel any difference. Same screen. And where it is going, who is processing? AOL. It is going to where? AOL. So by this example, we are trying to understand what is AOL. So AOL is providing what? Common feature or not? Isn't it? Isn't it? And apart from that, there are other things we will be discussing later. AOL provides features called profiles, flex fields. AOL provides flex fields, printers. Oh, so many things. That will be discussed later. This later. In system model, we have a later topic. Now you understand the basic idea. AOL is one of the technology module of e-business suite, which is the heart of e-business suite, because all the metadata is stored there. All the common features are provided by AOL. And then later you will be learning about profiles, flex fields, printers. So where we define printers? AOL. See, printers are using, who is using printers? GL module, AP module, AR module, but where they are defined? In one common module. What is that common module? What is the name? AOL. So you can say, or in short, you can say, what is AOL? It's a common module. A common module. Correct? You see, there are so many modules are there. Don't you think there must be one module which should be common to all? There must be some same information, right? So AOL. So AOL is a common to all business module. Okay. So you will be learning about AOL later, more. In one explanation, one single, here you can't get complete picture. Later. When you are learning about profiles, you are learning AOL. You are learning about flex field, you are learning about AOL. And I told you that apart from that, all the repository metadata. In e-business suite, how many forms are there? How many tables are there? Where is the information? In AOL. Okay, in AOL. Later, you know what? When we are going to deploy a custom form, when we are going to deploy a custom report, custom form, custom report, we need to register. Where we have to register? AOL. We have to register to it because AOL must know it, right? So when we are installing e-business suite, at the time of installation, all the information will be registered into AOL. Later, if you are creating any new table, custom table, or custom report, custom form, so we have to tell AOL, right? That is called registration. The process is called AOL registration. AOL registration. There are so many features are there. So this is very interesting module. So you people as an apps DBA must have a clear concept about what is AOL, and we'll be having discussion on it. And here at least the brief about AOL is that technically, so where you will find all the, how you find the AOL schema, all the AOL, AOL schema or AOL tables. How do you identify these tables and the prefix? What is the prefix? FND. So there are so many. Like for example, FND underscore concurrent request, FND underscore tables, FND underscore user. There are so many FND tables are there. We'll see that model. But the table, the prefix, if it is FND, means it belongs to what? AOL. FND, which is a short foundation. And then second most important model which you are practically going to use a lot is AD, application. Practically hands-on, you will be using a lot. Just FND tables. Second most important technology model is what? Application. Full application what? DBA. What's that? AD. You see, application DBA is a technology model which provides all AD utilities. It provides all the AD utilities. These AD utilities to perform different administrative tasks. Using these AD utilities, what you can do? You can do what? Patching, maintenance. Okay. You can perform various maintenance tasks. E-business suite maintenance task. Example of this task, what is the maintenance task? Patching is a maintenance task. Patching, okay, patching is there, compilation is there, sometime compilation, okay, compilation of database invalid, compilation of database invalid object, and there are so many things are generating forms, or a lot of things you can do. And not only that, plus even you can do what, let's say, cloning. So for patching, for cloning, you need various AD utilities, and all these AD utilities are part of which module? Apps3. So it is like this. There is a module called Apps3, and it has got various utilities, and using these utilities we are performing different tasks. Maintenance tasks, cloning, maintenance tasks. Cloning is also maintenance tasks. These are e-business suite maintenance tasks. So when you are using a utility for patching, when you are doing cloning, means you are using AD utilities, then you are working with which module? You are working with AD module. One of the module which you are going to use extensively is which module? AD module. And I can say here that Oracle has well organized all the utilities. Under which module? So all the AD utilities are organized in one module. What is that? AD module. Okay. So how Oracle is going to deliver new features to these utilities? Through which module? AD module. Isn't it? So all the utilities are controlled by which module? AD module. AD. Okay. So all the AD utilities, files, tables will be in one common location, because all the AD utilities belong to one module, AD module, and all the tables. Okay. So for all the AD modules schema, the tables, how do you identify? Prefix is what? AD. How do you identify this table belongs to AD module? It starts with what? AD. If the prefix is AD, it belongs to AD. So many examples are there. AD underscore bugs, which is store the information about the applied patches, bug fixing, patching information, like that. So many tables are there, AD tables. So anyway, you will be learning, we will be discussing more about AD, you will be learning practically about this module, patching, cloning and all that. Okay. But you must understand that it's a part of a module, AD module. Okay, AD module. So whenever you are in future, whenever you are doing upgradation, self-upgradation, so you have to know what are the new enhancements in the next release, what are the new enhancements made to AOL. So what are the new features have been added to which module? AD module. You don't look at individual utilities, you look at the module level. Enhancement at the module level, AOL. Enhancement to this AD module. So that means we don't need to know this functional model, GL, APR, they are not concerned with this. Functional people, they have to know all these models, GL, AP, AR, inventory, order management. We are concerned with this model. Now you understand which model we are going to use? AD model. AD and AOL. Sometimes we will be using AOL also. But your theoretical concept must be very clear as far as AOL is concerned. But practically you will be using what? AD. So these are two models, and then there are more technology models that we will see later. First these two, AOL and AD. Now coming back to this e-business suite schema. So what happened when at the time of installation when database is created, for every module one user will be created. For Oracle General Ledger, GL. Oracle Tables, AP. For receivables, AR. These are the names you have to remember. Huh? So Oracle General Ledger, AP, AR, fixed asset, C stand for cash management. All these are financial model. Okay, and then PO for purchasing, INV for inventory, and then this ONT for order management, and then you have this HR or human resources HR. Then you will be having this BOM with bills of material, working process for every module one user something. These are called product specific schema, product specific users or product specific product schemas. Products schemas or product users. And you know what? Each will be containing what? For all the GL, what? GL what? Tables, indexes, sequences, maybe some queues. Okay, so AP contain AP tables. So where you find inventory tables? Under INV. And this is ONT. ONT stands for order management, Oracle order management. This is the name of the short name of the model. You must know ONT. You remember this ONT. PO stand for not purchase order. It is purchasing. Oracle purchasing. PO means Oracle purchasing, or in short you can say purchasing. It's the name of the module. Purchasing. C stands for what? Cash management. So if there are 200 products are there, how many users will be created? 200 users. Product specific, product schemas, base schema, product schema for every. But for all technology models, there is only one common user. Now you understand common. All the GL tables in GL, inventory tables INV. But all the technology model tables are under Apple3. What are the technology models are there? AOL, all AOL, AD. So these belong to what? Which module? AOL, but owner is Apple3. This table belongs to which module? AD. And even we have a table called, the module called workflow. We will discuss about workflow later. Workflow tables. So all the tables, okay, FND, AD, WF, ALR, alerts. Of this part 2 we will discuss later. So all the AOL, AD, these are all technology model tables. So all the technology model tables, all the technology model schema is one user. What is the username? Apple3. So business modules separated. For each business module, separate user. But for all technology module, one user, common user. For all technology modules. So all the technology module tables, in simple language, tables, schema, data model is in one. Apple. And of course, we have to have more discussion on this integration and all that. In next session, I'm going to do that. Here, I'm just going to give you the names. You know that. Who is the application super user? The application super user is these apps. You know how are these apps? So apps provide a common access to all the tables. So how application can access tables from GL, API? It's a difficult enough because different users are not. So you know what happened? All the tables for GL will be created here, AP will be created here, and technology model tables are here. And not only tables, indexes, sequences will be here, and all these tables will be granted. Or even these tables will be granted to which user? Apps. That's why apps is actually it's an application super user, and we can what does it contain? You know, it contains universal schema. Why we say universal schema? Because you see, all the tables, 200 user, all tables, including AOL, all these tables will be granted to apps. And for every granted table, there will be a synonym in apps. For every granted table, there will be what will be created based on that? Synonyms. So tell me, to which user we can access the entire business suite data model? But where are AOL tables? In Apps. Apps is not the owner of any table, but it has full access on all tables. So for today's session, can you just tell me one just one day? Can you, like, you know, we have in database we have two users, base sys and system. So can you just compare this, sys and system with what? Like Apple sys with Apple scissors. Okay. In your database, who is the owner of data dictionary? Data dictionary. He is the owner of AOL technology. Sys. In your database, who is the super user? SysDB. SysDB is not a user. SysDB is a privileged role. System. Okay. Most of the people are confused. Sys and system. Yeah. Sys is the owner of data dictionary. Sys is not a super user. System is a super user. System is a super user. Okay. It's not my mistake. In my class I tell 10 in coding here. People forget, I can't do it. System. So you compare system with what is sys is here we have Apple sys. What is we have system in database is apps. Compare it. So they are analogous, right? The sys is analogous to this Apple sys and system is similar to apps. Comparing that. So in a database you can access any table from system. And similarly, apps can access any table of application users. So that's why they are comparing. Because sys contains the AOL, sys contains the data, data dictionary, the metadata, and here Apple sys contains the metadata. That we are comparing Apple sys with sys. So here you must understand that you remember which user has access to entire e-business suite data model, every single apps. And you know what? At runtime, every module, GL, APA, all modules are going to connect to which schema? I know Apps3. Because it has access to all the tables. And tomorrow next session, it is not a complete discussion. This is the beginning. We have to discuss so many things here. How at runtime application modules are going to access apps, how they can access the data, okay, and how the integration is maintained. Oh, they are very important things. So whatever we have discussed is very important. And again, what we are going to discuss again very important for you people. These two things: understanding e-business to data model and application file system. Okay. Later, how good you are going to be in general administration, managing services, or in patching. Okay. Your concept in patching, your patching concept, your cloning concept will depend on these classes. You understand? Today, these topics are clear. This data model, file system. Then your patching, cloning will be clear. If you are going to have any problem here, then there will be any problem. So in advance I am telling you. So you are going to have problem in patching and cloning. If you are going to have problem here. So here you understand first, put efforts and understand this. Then your patching concept, cloning concept will be this is base. Because when you are applying application patches, the patches will be applied on these users. So you must know, when you are applying patch on GL module, which schema is coming in? GL schema. But GL schema has relationship with app schema also. Because it has granted all the tables. But there are more things we have to discuss. So we will continue this same topic tomorrow in the next session, and we are going to discuss about application file system. If possible, you go through this data model further from your side. Any question from you? Which user? Schemas and models for this model. So there are so many ways out there you can find out. From the front end you can find out, from the back end you can find out. By directly connecting. And listen, there's no need to find out. It's a fix, very fine. Must fix, always fix. You go anywhere in the world, you will find GL. So you know you. GL will be there, GL will be there, that's it. No need to find out. Auto generation GL, that's it. Apps, always apps. Any question for me for today's session? So more about e-business to data model, more about application file system. When we are talking about e-business to data model, we are trying to understand the back end. And when we are looking at the application file system, we are trying to understand what? Front end. Application front end. So you need to have the complete e-business to back end knowledge and the front end. How the data model is maintained in the database, how the files are organized in the file system. And in the file system, we have to discuss the same thing: Apple top, common top, 10.1.2, 10.1.3, and last INS. Apple top, common top, text stack, INS. and this data. Just remember this GL, APR, C, PO, INV, this. But I'm going to discuss more here. Okay, is it clear? All the technology models are in one, but it's okay. The tables can be identified. All the F&D tables belong to which module? AOA. User is common, but separate models. It's okay. And you know what? As an Apps DBA, as an auto DBA, let's just start with DBA. You are DBA. So as a DBA, you know, you will be having good control over database when you have good knowledge about what views. You agree with me on views, right? You have to know more data relational views, more performance dynamic views, $3 views, isn't it? If the person is saying that I know more views, means naturally he has got good control. So as an Apps DBA, you have to have good knowledge about this. F&D tables and tables. Very important. So a lot of things you can find out from the back end about information about the application from the back end with the help of which tables? And tables. These two tables are very important. So same thing, same part, I'm going to continue tomorrow. Later class.